Okay, welcome you guys to our first recording together. We'll see how it goes. It is a little weird talking to myself here, but today, first I want to talk about rationalizing. Okay, rationalizing, we talked about that. Again, it just means clearing roots from the denominator. And next time I'll write that out beforehand. Let's do a few problems together now. So number one, let's rationalize. Let's start with something simple. 3 over the square root of 5. Okay, we want to rationalize that one to get rid of this root. We can't just put them all under one big root because this is not a square root. Rather, if we think backwards, we want this to become the square root of 5 squared. Because if it does, then just the denominator here is going to equal just 5, and that's our goal. Well, what can we do to accomplish that? We can multiply this denominator by the square root of 5. Because if I do that, then I'll have square root of 5 and the square root of 5, which is square root of 5 squared, which is 5. Of course, you cannot just do that in the denominator. We have to multiply in the numerator as well. That's an equivalent form of 1. So we're going to get 3 root 5 over 5. Okay, let's try another example. Number 2. Let's say we have the square root of 8x over the square root of 4x. Now this example is kind of different because we've got square root over square root, so actually technically we could do an easier job of just putting it under one big square root, but let's just pretend we forgot how to do that. Our goal is to make a square root with 4 squared and x squared in here so that that can all come out and be just 4x. Well, what is it going to take to get that? We're going to have to multiply by the square root of 4 squared. Oops, not 4 squared. Silly me. We're going to have to multiply by the square root of 4. I'll just cross that out for now. All right. 4x. Basically the same thing. Numerator and denominator to make an equivalent form of 1. So we're going to get, if we multiply it inside here, the square root of 32x squared all over 4x. And I can simplify that. Square root of 32x squared is 32. I can break that down into the square root of 16 times 2. 16 is a perfect square. It's 4 squared. So basically the 4 can come out, the x can come out, so we're going to get 4x square root of 2 all over 4x. And now the 4's can become 1, the x's become 1, and we are left with the square root of 2. All right, let's keep going with this. Let's do another one, number 3. Number 3, let's try a cube root now. So 2 over the cube root of 2y. Okay, so again, let's think backwards here. 2 over the cube root of 2y. Our goal is we want this to be the cube root of 2 cubed y cubed. Because if I can do that, then I'll get this will all just come out, I'll just get 2y. Okay, so what are we going to multiply by? It's not just the cube root of 2y anymore. So let's just take a look here. Multiply by the cube root of, well, I need 3 2's. I have just 1, so I need to multiply by 2 squared. Right now I have 2 cubed, in other words. I have 1y, so I multiply by y squared, and now I have 3y's, which is exactly what I wanted. 3y's. So we get numerator and denominator, of course. Cube root of 2 squared y squared, or 4y squared, if you will. So we're going to get 2 times the cube root of 4y squared all over 2y. Okay, last 2 examples. Number 4. Let's try a 4th root. Let's do x over the 4th root of x. X over the 4th root of x. Again, picture what you want. I want this to become the 4th root of x to the 4th. Well, What do I need to make that into a fourth root of x to the fourth? I need 3 more x's. I have 1 here. I need 3 more. X times x cubed. Now we have x to the fourth. So, fourth root of x cubed over fourth root of x cubed. That's an equivalent form of 1. So we are going to get x times the fourth root of x cubed. And we'll talk about how to kind of put that all together later, all over x. And we have x over x here. That just becomes 1. So we get the fourth root of x cubed. All right, we're doing good. Let's just do one more example here. One more example, number 5. Let's call this, so let's do square root of y over the fifth root of 3y. Okay, so again, we need this to be the fifth root of 3 to the fifth, y to the fifth, right? That's our goal, because then we're just going to get everything comes out just 3y. What is it going to take for us to get to the fifth root of 3 to the fifth, y to the fifth? Well, we need, let's see, looks like we need 4 more 3's. So 3 to the fourth, y to the fourth. So 3 to the fourth, y to the fourth. Again, we're just multiplying by 1. That's just a 1. So we're not changing anything. And since these are two different indexes, square root and fifth root, we can't combine them, so we're just going to keep them separate. We're going to get square root of y times the fifth root of 3 to the fourth. That's 3 times 3 times 3 times 3, 81 y to the fourth. And this ugly thing is where we're going to leave it. Okay.